Great.
Hi, everyone. Thank you for taking your time to be present here. So the purpose of this presentation is just to talk about what are the electrical and mechanical engineering projects, what separates them, what is the difference between them, and so also provide some ideas on what kind of research projects you can do in either electrical engineering or mechanical engineering. And as Rebecca mentioned, please feel free to post questions in the chat, and you can wait till the end to ask any questions after the presentation is done. Uh, so So the way we'll go in this presentation, we will talk with an introduction and a welcome. Then I will use an example of a current very popular technology, which is electrical vehicles. We will identify what are some electrical components, what are some mechanical components. We will then go over some ideas for mechanical and electrical engineering projects. Then how you can leverage AI tools to help you do your research, and then some other things you can use AI for. We will definitely talk about safety best practices, because safety first on all your projects, to protect yourself and to protect your projects and those working with you. We will talk about some career pathways that you can pursue as a mechanical engineer or as an electrical engineer. And then at the end, we will also talk about MATLAB resources. MathWorks has offered free MATLAB to all participants in the science and engineering fair. So we will provide, I will share a link as a part of the presentation where you can download MATLAB for free, and also all the resources that are available for use. And also we'll talk about a very interesting upcoming webinar where you will work hands-on with MATLAB and learn some really cool data analysis techniques. So to start, hi, my name is Shrikant Kapali. I can also go by Shri if that's easy to pronounce. I'm currently a senior engineering technical writer at MathWorks. So in this role, my goal is I am the voice of the customer. So I work with the developers, we develop features, and then I document that. So any documentation you find on mathworks.com/help is written by technical writers. There are about 200 of us, and this really helps accelerate the pace of engineering and science. I'm an electrical engineer by background and by education. I have a master's in electrical engineering from Clemson University, South Carolina. And I also have 12 plus years of control engineering experience. So I have worked in steel mills around the world, and I've also done food and beverage conveyor automation, and also automation of the machines which deliver your UPS packages all around the country and the world. It's really fun to see a machine going at 300 feet per minute, and then the packages are just flying off into the bins on the side based on the zip code and camera. So that's some cool technology that I've got my chance to work with, and also been a FIRST Robotics judge and mentor for 17 plus years. So I'm really passionate about educating the next generation of scientists and engineers and sharing what I have learned, and hoping to inspire them to continue pursuing this career path, because we really need a lot of good scientists and engineers in the upcoming years. So first, a very common technology that we see out today are electrical vehicles. So here in the slide, I've just identified a few components. So the key, all the electrical components are marked in red, and yellow is used to mark the mechanical components. So some common mechanical components in electric vehicles, or any automobile for that, is the suspension. Without suspension, you're going to have a very rough ride. So suspensions tend to be predominantly mechanical. They either have like a dampener and a mass system, or they tend to have some either pneumatic or hydraulic systems, wheels, and then all the physical parts that you can feel, like gears, all those tend to be mechanical. The key electrical components will be the power electronics, which convert like DC voltage back to AC voltage to run the motors. Then the motors are going to be electrical, but the motors also have mechanical components in them. They have bearings, they also have lubrication to keep them running to reduce friction. Those are some mechanical components. So I just wanted to get an insight of how we can differentiate between electrical and mechanical components. So what are some mechanical engineering project ideas? So the first one is, we all have the side view mirrors on our vehicles. There is some talk about, do we really need the side view mirrors? With good cameras, now you're able to see all around the car. So a good research project would be to see, you can simulate and see how the side view mirrors affect the vehicle aerodynamics. Is it increasing drag or reducing drag? And is that is going to increase your battery range or decrease your battery range? So that will be a fun project to see. You can do some simulations, or you can just do a simple setup. So one good project would be the effect of side view mirrors on vehicle aerodynamics. The other one, which is very popular nowadays, is drones. So you come drones which have like 4 propellers or 8, then the propellers can rotate. So another interesting project will be to analyze different layouts and see how they affect the lift on the drone, and in turn, how they affect the battery life of the drone. So that's another interesting mechanical engineering project. Another popular thing right now is e-bikes. And again, with any electric vehicles, the key is the range. So how can you improve, how can you plan the gears, or how can you design the frame of the bike so that you increase the battery range and reduce drag, reduce friction, and what kind of gear ratios you can choose. So that is another interesting project that you can take on in the mechanical realm. The other one is, when summers are getting hotter, and then we all are like the cold air is not reaching us fast enough. So how can we optimize the climate control inside cars by seeing where we can position the air duct? So you can do some sort of mechanical engineering and computational fluid dynamics analysis to see where to position the ducts so that you can get the optimized range and you can cool the car down as fast as you would like it. And then this is like a thermodynamics concept. So there is something called a Q-cycle engine. This is used in some steel mills around the world because the furnaces tend to get really hot. So they recapture the waste gases and then they are able to reuse the waste heat. So just doing a project like how big would the Q-cycle need to be to capture some waste heat in homes during the heating and winter months, and how to reuse that heat. So some sort of analysis and coming up with some sort of design or some sort of mechanism, I think would be another fun, interesting mechanical engineering project. So these are some of the ideas I came up for with mechanical engineering projects. Now we will move on to electrical engineering projects. So again, motors tend to be a very common component. So you can compare the performance of, say, regular DC motors, and there's a new technology called brushless DC motors, and you can see which one is more efficient in performance. The reason brushless is old DC motors used to have something called a commutation brush. So when you had to go from forward to reverse, these carbon brushes would come in and they would reverse the direction of the motor, and that caused a lot of like friction, and it would reduce the efficiency of the motor. So it would be a good study to see which ones are more efficient and how you can improve the efficiency and using, and what are some applications for brushless DC motors. The other common, so all the electric motors need control algorithms. So you need to control the motor speed, and then you have to, so you can use some simulation software and you can try to come up with some new motor control algorithms for electric vehicles, because again, it's all about increasing performance. It's all about increasing efficiency. So what are some motor control algorithms that you can simulate and see how they increase vehicle performance? These days, cars have a lot of wiring, and that's causing a lot of problems. The amount of wiring in cars has gone up by 10 times in the last 5 years. So you can just do a research project to see, okay, how many sensors do we really need? Where do they need to be placed? And how do the motors be arranged? And how you can break up the wiring so you can overall reduce the amount of wiring and also make cars easier to troubleshoot, electric vehicles or any regular cars, easy to troubleshoot, reduce the amount of wiring, because that also has an impact on the environment. The less wiring that we use, the less amount of copper or other things that we have to use. So how do we reuse that, and how do we reduce the amount of wiring? Another common one is in your homes. I'm sure many of you are familiar with Arduinos and Raspberry Pis and all these cool devices. So you build some sort of gadget to monitor the power usage in your homes, and then you can see, oh, this all of a sudden my washing machine is drawing more power than it should. Is it about to fail, or why is it drawing so much power? So just doing some sort of analysis, that would be a good electrical engineering project to work on. So those are some of the common project ideas. So now we will come about how do you use AI? So we live in the generation of AI. Every day there's some new AI tool coming out. There is like Perplexity, there's ChatGPT, there's Google Gemini's. So I broke it down into two broad areas. So one is for research and information gathering. I find AI very helpful in understanding very hard engineering concepts and working on first principles. So I would say something like, I'm a brand new user, or I am a junior in high school and I want to understand this engineering concept. Can you explain it to me like you're explaining it to, like, say, like a 10-year-old or a 20-year-old? And AI gives, but again, you have to trust but verify. So go through the answers, but also research multiple sources to make sure that it's putting out the accurate information. But I find it a very useful research and information gathering tool. So you can find a lot of good links and resources that you can use as you're doing your research. And again, you can use it to quickly perform research and find additional reading material. So it always recommends, like, oh, you can read this paper, and the follow-up questions are also good. So you can just take a deep dive, and then you can build up a good source of information and material that you can read as part of your research project. The other application that I find helpful is to quickly generate and test code. So now you can quickly, MATLAB has a new Copilot, which I think should be available as part of the MATLAB free software license. But even if you use like Claude AI or even Google Gemini, you can quickly say, oh, I have this data. Can you just help me start with an initial function to analyze the data and do a quick plot? So it quickly generates the code. You can test it out, and then you can see that if it's working or not working. So you can quickly prototype code. And even if you get error messages from the code, it's helpful to put the error messages in there and say, I'm running into this particular error message. Where do you think the problem is? Or what are some things I can do to debug the code or troubleshoot the code? So I think these are two broad applications that you can use as you're doing your research projects. One is for research and information gathering, and the other is to generate and debug code that you're going to use as part of the process. Again, I came back to, so safety first. You have to protect yourself and your projects because that's of the utmost importance. So when you're working on mechanical engineering equipment, always wear protective gears like eyeglasses, gloves. Always make sure that you're trained to use the machinery that you're using. Keep the area around the machinery clean. Make sure there's nothing blocking you from either going away from the machine or towards the machine. Maintaining your tools, making sure that they're well lubricated, put them back in the place where you took them out of, and keeping a clean and organized workspace. These all promote safety. And it keeps a clutter-free environment. So you're able to do your experiments in a quick manner, in a proper manner. You can follow procedure. So it's very important to maintain safety of mechanical equipment as you're doing your mechanical engineering or any research engineering projects. Electrical engineering safety, insulation integrity. So always check the wires to make sure that the wire is not exposed and that the metal under the wire is not exposed. You don't want to electrocute yourself or cause some sort of short circuit. So always check the insulation integrity. Make sure you're trained on the live circuit protocol. So you know how to turn off the machine if something goes wrong. If there's like an overload, you know where the safety switches are, or there's someone adult trained to turn off the safety switch. Grounding, always make sure that you have ground fault interrupters. So if anything gets grounded, that the circuit trips and does not damage the equipment or electrocutes you. And always be aware of the current ratings that are useful and include these as part of your safety and research plan. It's very important to know what kind of voltages and currents you're dealing with when you're working with electrical engineering equipment, so we can make sure to approve the project and make sure that you have the proper safety protocols and tools to help you do those projects and research projects. So what are some mechanical engineering career pathways? So the first one, which is very common, is automotive engineer. So as a mechanical engineering automotive engineer, you research new kinds of steel to build the chassis of the car, from how to reduce the weight, how to use aluminum composites, then what kind of gear ratios to use, what are some new lubricants that are applicable, which have a long life and which also increase efficiency and performance. Aerospace engineers, very common. So the planes that we fly in and that we use for transportation. Again, it's all about materials. It's about the hydraulics, because hydraulics is very common in aerospace because it's a very easy way to move large pieces of equipment with less amount of force. But how do you learn hydraulics? How do you design hydraulic systems? How do you maintain them? What are the safety requirements? So these are some of the things that mechanical engineers work on. As a robotics engineer, so the robots have like robotic arms. So again, it's a lot of mechanics, it's gears and linkages and movement mechanisms. How do you understand those? How do you make those more optimal? How do you make them more efficient? Those are some of the roles of a mechanical engineer as a robotics engineer. And then HVAC, we all need ventilation, heating, and cooling, especially for data centers now. Data center HVAC is becoming more common because you have to keep the computers cool to a certain temperature for them to be efficient and consume less power. So learning about HVAC, and that's a lot of like thermodynamics and computational fluid dynamics. So mechanical engineers play a key role in each of these four industries. Now coming to electrical engineering, power systems. So you have to transmit power from one place to the other. Without power, the computers are not going to turn on, nothing's going to run. The AI data centers are going to shut down. So you need power system engineers, and the grid is going to get smarter. We're talking about smart grids and upgrading the grid infrastructure. So these are some key roles for electrical engineers to play in these fields. Then electronics design engineer. If you open up your smartphone and look, there's a bunch of chips. All your computers have chips. There's components like resistors, capacitors. So designing those, understanding how those work together, like building in the Bluetooth protocol. All these are the roles of electronics engineers and RF engineers. So understanding electrical and electronics is very key part of designing these circuits of the future. Again, coming to control systems engineers. So here you have the breakaway section of a plane. There's tons and tons of there's specialized computers which control the hydraulic valves, which then actuate the wings and the flaps for takeoff. But learning how to control those, like understanding them, modeling them. And again, this can be a common area between mechanical and electronics engineer. Control systems applies to both, but it's a common field. You have to know how the mechanical equipment works and then how the electrical equipment is going to control the mechanical equipment. So that's a key work area for electrical engineers. And then embedded system. We all now have Apple Watches, which are monitoring our health, and it's all running embedded code. But again, there's sensors in the back. They have to reduce the wiring. The circuits are getting smaller and smaller. So how do you optimize the design? Are we using FPGAs? Are we using any kind of new chips? And to be a really good embedded engineer, you have to understand the hardware well. And that's why the electrical/electronics engineer comes in. You have to understand those components, how they work together to really, truly program them in an optimal way. So these are some of the electrical/electronic engineering career opportunities available. So now we will come to this slide. So this year, MathWorks is a key sponsor of MSIF. And so we have a resource where we provide free MATLAB for students. Let me. So you can download the software for free here. You fill in the software request form and say what project you're working on, why you need the software. And then I would definitely say that take the MATLAB on-ramp course. It's a very good course to get started. It gives you all the basics to get started at MATLAB programming. And then we have a bunch of other resources in there. You can take online courses, there's dedicated tutorials, and then based on what project area you're working on, you have a ton of available resources. You can look at the documentation, you can look at previous projects and really get you started with the MATLAB. And then the other thing is, I want to plug in, we have a very interested upcoming webinar, which is run by my colleague, Kathy. It's going to be talking about an intro to data analysis with MATLAB. So here you will work with MATLAB hands-on, and we will walk you through a scenario and how do you take data, how do you do analytics, clean it up, how do you do presentations if you want to build like machine learning models out of it. So it's a very interesting webinar, and I highly recommend if you have the opportunity to attend that webinar and make use of these resources that are available. So yeah, that was my presentation. So thank you for being here and listening. And now I have access to some questions.